Imagine shrinking the universe down to a tabletop. Our entire solar system would be a speck. The sun, the planets, even the distant edge of the heliosphere would vanish into insignificance. And then, towering over everything, would be monsters so vast that they warp space and time itself. Now imagine those giants crashing into each other. What would really happen if the largest objects in existence collided? This is not just cosmic destruction. It is the story of how the universe reshapes itself. When the biggest black holes in existence meet. Black holes already feel like the final bosses of reality. Even the smallest stellar black holes can outweigh the sun while being smaller than the moon. But these are nothing compared to supermassive black holes, which sit at the centers of galaxies and contain millions or billions of solar masses. Our own galaxy's black hole, Sagittarius A, is about 4.3 million times heavier than the Sun. Large enough to swallow Mercury's orbit, yet still tiny on the cosmic scale. Now zoom out. At the extreme end of nature sit ultra-massive black holes. TON 618, one of the largest known, holds tens of billions of solar masses. Its event horizon would stretch far beyond the outer edges of our solar system. And then there is Phoenix A, an even more outrageous object, tipping the scales at roughly 100 billion suns. These are not just heavy, they are ancient. Objects of this size likely formed very early in cosmic history and have been growing for billions of years, feeding on gas, stars, and even entire star clusters. So what if two of these titans met? This would not look like a crash. There is no explosion, no fiery impact. Instead, it begins as a slow gravitational ballet. Placed in the same galaxy, the two black holes would spiral toward each other over millions of years. They would orbit, closer and closer, distorting space-time with every pass. As they approach, they begin to stretch and warp each other's event horizons, like two dark whirlpools pulling together. At the final moment, they merge. The collision releases more energy than all the stars in the observable universe combined, not in light, but as gravitational waves. These ripples in space-time race across the cosmos for billions of years, permanently reshaping the structure of the universe. Then silence. The newborn black hole settles down and continues feeding, as if nothing dramatic happened. The universe barely flinches, yet space-time itself has been permanently rewritten when entire galaxies collide. If black hole mergers are subtle ripples in reality, galaxy collisions are slow-motion cosmic epics. Our Milky Way is already drifting toward the Andromeda Galaxy at more than 100 kilometers per second. In roughly 4 to 5 billion years, the two enormous spirals will begin to merge. This is not a rare event. Across the universe, galaxies constantly collide and combine, and these encounters are one of the main forces shaping how the cosmos evolves. What makes this counterintuitive is that galaxy collisions are far less destructive than they appear. A galaxy may contain hundreds of billions of stars, yet it is mostly empty space. The average distance between stars is several light years. That means even when two galaxies overlap, the odds of two stars physically striking each other are incredibly small. Galaxies look like solid objects in photographs, but in reality they are vast, ghostly structures made of scattered points of light drifting through near vacuum. As the Milky Way and Andromeda pass through each other, they will not explode. Instead, gravity will slowly tear them apart and remake them. Their elegant spiral arms will stretch and twist like taffy. Streams of stars will be pulled into long tidal tails that arc across intergalactic space. Massive clouds of gas will slam together, compressing and collapsing to form millions of new stars in violent bursts of starbirth. Entire solar systems will be thrown into new orbits, reshuffled inside a growing hybrid galaxy. Over billions of years, repeated passes will drain orbital energy. The two galaxies will lose their separate identities and settle into a single, much larger system, likely a giant elliptical galaxy. From chaos, a new structure is born. At their cores, however, something far more dramatic unfolds. Each galaxy carries a supermassive black hole at its center. As the galaxies merge, these black holes sink inward through gravitational interactions. Eventually, they form a bound pair and begin a slow orbital dance. Over millions of years, they spiral together, radiating gravitational waves, until they finally merge into one even larger black hole. Galactic collisions are therefore not merely acts of destruction. They are cosmic construction projects, building bigger galaxies and more massive black holes that shape the large-scale architecture of the universe. When giant planets collide. Stepping down from galaxies to planets, the scale shrinks, but the drama remains. Jupiter dominates our solar system, holding more mass than all the other planets combined, and large enough to fit more than 1,000 Earths inside it. Yet astronomers have discovered exoplanets even more extreme, gas giants nearly 13 times Jupiter's mass, teetering on the boundary between planet and star. If two such titanic worlds were to collide, the event would look nothing like an asteroid impact. These planets are not solid bodies. They are enormous spheres of hydrogen and helium. Their collision would resemble the violent merging of two planetary storms the size of continents. As they crash together, shockwaves would rip through both planets. Vast quantities of superheated gas would be blasted into space. For a brief time, the system would glow intensely as gravitational energy converts into heat and radiation. But rather than shattering into fragments, the two giants would most likely blend together under their own gravity, collapsing into a single, heavier object. This is where planetary physics crosses into stellar physics. If the merged world exceeds about 13 times Jupiter's mass, it becomes something new, a brown dwarf. Brown dwarfs are often called failed stars. They are too small to sustain full hydrogen fusion like true stars, yet massive enough to fuse heavy hydrogen and glow faintly in infrared light. In effect, two planets can collide and create a new class of cosmic object, halfway between planet and star. In this case, a collision does not end a world, it upgrades it. The universe quietly promotes a planet into a new rank of existence. When the largest stars collide. Stars are already enormous engines of nuclear energy. But some stars push the limits of physics. Certain hypergiant stars contain more than 100 times the mass of our Sun and shine millions of times brighter. These monsters burn fuel at such extreme rates that they live fast and die young. If two ordinary stars collide gently, they may merge into a single larger star, called a blue straggler. This new star appears younger and hotter than its neighbors, rejuvenated by fresh fuel. But with the biggest stars in the universe, things can turn catastrophic. If two hypergiants collide at high speed, the energy involved is unimaginable. Their combined gravitational and kinetic energy can completely tear both stars apart. Instead of forming a new star, the collision can obliterate them entirely. Their hydrogen is blasted into space so violently that it can never reassemble. No remnant star remains. Two of the brightest objects in the galaxy vanish in a single cosmic catastrophe. This is one of the rare cases where a collision truly erases objects from existence. The pattern of cosmic collisions. Across every scale, from planets to galaxies, the universe follows the same rules. Slow collisions tend to merge objects into something larger. Fast collisions tend to destroy them. Black holes merge quietly. Galaxies reshape each other gently. Giant planets can combine to form new classes of objects. But massive stars, when they collide violently, can annihilate each other completely. These events are not just spectacles. They are how the universe evolves. Galaxies grow through mergers. Black holes gain mass through collisions. New stars are born from the debris of older systems. Even destruction becomes a tool of creation. The universe is not a quiet place. It is shaped by colossal impacts, slow-motion collisions, and forces beyond imagination. And every galaxy, star, and planet you see today is the result of ancient cosmic encounters. If you enjoyed exploring these mind-bending events and want more journeys into the deepest mysteries of space, make sure to like and subscribe, and I'll see you in the next one.